In this video, I'm going to make the velocity versus time graph for the bowling ball motion. In a different video, I made the position time graph, which is this one, which is the position on the y-axis and the time on the x-axis. For this one, we're going to make a velocity time graph for this, and for that, we're going to need to calculate some velocities. So I'm going to label these velocity 1 and the velocity 2 and the velocity 3. And to find the velocity, what we're going to do is we're going to take these little tiny distances, 5 meters, and divide by the time it took to do each one of them. And we're going to put that at the end of the interval. We call these the interval velocities that are little average velocities for a short period of time. And so this is the only time we have data for is this 2.52 seconds for 5 meters. So I'm going to have to make a formula. So we start a formula by telling it equals. And what I want to do is take the distance or the displacement, which for these is 5 meters every time. I'm going to divide it by, and I'm going to need to open a parenthesis here. We're going to divide it by the time it took. To find the time it took, we just subtract the 2 times that it took to get to 5. So Excel will let us just click on that one to put that one in, and then we're going to subtract the time that happened before. We're going to click on that one. Notice that this one's blue and this one's green now. And then we're going to close the parenthesis. All right, there's the formula. So it's going to take 5, which is a distance for each one of these little intervals. All of them are 5 meters from the previous one. And divide by the time it took, which is this times this. Or, I'm sorry, this minus this. So I'm going to hit enter, and it's going to put that number in there. Now, if we look up here, there's the formula. Now, here's the cool thing about Excel. Down here in this corner, you see there's this little box. If you put the cursor over there, the cursor changes to a little plus sign. And if you then click and drag down, it will copy that formula down and change the formula corresponding to the next box. So notice, okay, here was the original, was B3 minus B2. Below it is now B4 minus B3, so it's the difference between these two. And not only that, if we highlight all of these and then grab this corner and pull this way, it will now take, if you look at this one, now it's the difference between these two. This one's the difference between these two. And voila, we are actually already done now with finding all of these velocities. We didn't need a calculator. All we need to do is type in one formula, and there we go. All right, so now we're going to make the velocity versus time graph. I'm not putting the zeros in there because I don't know what the initial velocities were, because the only way I can find the velocity is if I take this distance of 5 and divide it by time. So this is not 0. The velocity that we're talking about here is the velocity it had when it left the thrower's hand. So if we're going to make a velocity time graph, we're going to need to highlight all these times and all these velocities. And we're going to insert, again, a scatter plot, not a line graph, a scatter plot, x versus y, this one. And it looks like a mess, and it is a mess. So we're going to click inside on nothing again. I want to move it to a new chart, because moving it to a new chart makes it big and also makes it print on a full-size piece of paper. I'm going to do this. Choose this first one because it's going to put the axes titles in here, and these are time, which is in seconds. And over here is velocity, which is in meters per second. And let's call this one rolling along. All right, now this is a mess. So they're all stacked up on top of each other, and it doesn't really tell us anything. That's because we need to select the data because it's been confused about what we want it to do. So there's a whole mess, and see, everything here is highlighted like it's supposed to be, but what we want to do here is choose one of these series, just choose series 1, and edit that. And over here, we're going to use these pictures on the side. Don't click inside these things. Things will get confusing. Just click on this first. This is the x values. Click on that. For the first x values, we want the times, because the time goes on the x-axis for the first set. So that. And then we're going to click on the picture down here for the y values. And the y values that go with that are these first velocities. That's why I numbered these at the top, so you can keep track of that. All right, and we're going to say OK. And then we're going to do that same thing for series 2. We're going to edit it. We're going to go down here to the x values. We're going to highlight the x values. That. We're going to highlight the y values, which are these velocities, number 2, like that, and say OK. Then finally for the series 3, exactly the same thing, edit it. X values are these third set of times, like so. Y values are going to be these set of times, like so. And say OK. Now you'll see there's still some series left. They are junk. You can just remove them. Series 4, Series 5, just remove those. And I have this, which is really kind of a mess. But there is a kind of downward trend here, which I think we might expect because we are talking about a bowling ball that's rolling and it should be slowing down. So let's put trend lines in. I'm going to click on this first one, right click, add a trend line, put in the equation, r squared. It's still suggesting linear. I don't see any reason not to pick that. That was the red ones. Let's do the green ones. Click on it, right click on it, display equation, see what the regression value looks like. These regression values are not very good. You can see this one's 0.6. Remember, 1 is perfect. It means that the line perfectly represents the data. This one's pretty terrible at 0.1, but that's what we got. Blue ones here, click and right click, add the trend line, display the equation, r squared value. It's still linear, that's good. All right, that was this one. And this one goes with that one. R squared values here are, again, not, oh, actually, that one's pretty good. That's better than the other one, as it turns out. Okay, so this is the velocity versus time graph for the bowling motion. All of these have negative slopes because this is in y equals mx plus b format, slope-intercept format. They all have negative slopes, which we kind of would expect because we would expect the ball to be slowing down. All right, so there is the velocity versus time graph for the bowling ball motion.